Our next speaker is Bryan Bibat. He has been the resident videographer for the Philippine Ruby users group for the past 6 years and has covered almost every RubyConf. Okay, he was a speaker at the first, so I think he was like me. He didn't want to be worried about recording. He's currently a senior developer at Logica. Bryan Bibat.
Right. Hope you had a great lunch. I think you're getting sleepy now. So, yeah, it's okay to sleep. My talk is just okay. Anyway, this is another Rails performance talk. And again, I'm Bryan. As mentioned, I am Bryan. Let's just see if the slides are working. If it's not, we'll have to. Yeah. Okay. So I'm Bryan, it's Bryan Bibat. I take videos for Frog. You can find me at those sites. I've been doing this for quite a while. And again, my talk is about performance. And this is, the name is just First Aid. I could have used Quick Wins, but good thing I used First Aid. And good thing it's after lunch I had time to trim my talk. And I want to trim my talk because, again, I'm the videographer. Right now, I'm using lots of devices. I got multiple cameras, and I've been running around, so anything can happen. So, I don't know. I'll try to keep this talk quick. Anyway, apart from being a videographer, as I said, I'm a software developer for Logica. We have a booth there. Our office is just down the street, a block away, and our main thing is to provide, again, these stuff, app development, team augmentation. In case your development team needs specialized skills or additional help, we can provide that type of support. And you can't see it much. It's rescue ops. In case your development team went AWOL, we can come and solve your problems. Anyway, so given that that is our type of work, I get to see more than the usual amount of different code bases. So I can see old code bases, and we have our own code base. So as I look through that, I see a trend in what are the common performance problems, performance flaws on those applications. Anyway, I'm getting ahead of myself. So the talk is about Rails performance, the second talk for the day, and as we all know, the best way to improve the performance is to rewrite everything. The main thing hanging over our heads is the whole idea that Rails is slow. It's somewhat true if you compare it with other languages, but when you look at it, the whole thing is just riding on the hype. So Rails and Django got a good amount of traction, and if you want to gain the same amount of traction, the easiest way to do it is to say that your new thing is a lot faster than the old thing. So yeah, there's a bit of truth in that, but ultimately Rails is actually fast. It's fast enough for most people's use. There's this famous, blog post by DHH about Ruby and Rails being fast enough in 2003, and as the years go by, it became faster and the servers became cheaper. So, in our experience, Rails, if done right, it can serve your purpose most of the time. And the idea is, if you are good at doing what you have, you need to sell that stuff or sell that service so you can get money, and if you reach the limits of your application, you get to buy more servers. Unlike the other types of systems that really need performance, they have a different use case. They earn a lot less for more customers. But since we're usually providing direct services, you have to find a way to market it, to monetize it, so that you don't need to worry about really optimizing your applications. So again, my talk is all about first aid. As I said, it's the only thing that I can think of about my talk, because point is, what I'm going to do here is talk about stuff that isn't surgery. I'm like what Will was talking about, we're not going to gut your app or rewrite it in a different framework so that you can post something on Medium. So anyway, these are just the things that you can do even maybe when you come to work on Monday. These are just basic things that you can do to your app. And we talked with Will, so what I'm going to talk about now is not really the same. So these are additional tips. And for the seniors here, this is mostly a review. For the newbies, this can help you see what you can look at to improve your applications. Since this is first aid, we'll try not to add additional expense to your systems, especially us. We're providing service. It's hard to tell the client that you have to buy additional servers. So this first aid part, just try to have as little extra expense apart from the expense of the salary of your developers, spending a week or two or a few days to improve the performance of the app. Also, we're not going to talk about JS. This is not a JS.conf, and you might notice that a lot of your performance problems can come from your apps not loading fast enough. We'll try not to talk about that. Anyway, first things first about performance is to focus on what matters. When you talk about performance, it's usually these two things, whether it's your response time or what you can call latency, how fast the application loads in your user's browser or user's app, or the amount of people who can use, amount of users, amount of clients that can use your application. So these two are related. So if you have very, very high response time, most likely your servers will get bogged down, so you're going to get less concurrent requests. But the opposite may or not be true. You have, say, 100 servers and you've got a big response time, but you still have a lot of slack to reach the limit of your server. The point is that your application is just slow. It's not a problem in your server. So they are interrelated, but when you want to focus on something, either latency or throughput, there are slightly different approaches to those. So for this talk, I'll just mostly cover about latency. Okay, so I'll just give a quick example of improving the performance. So let's look at the page load time. So the page load time can be broken down into the network part, the browser trying to connect to your server. So there's the initial DNS lookup. Then there's also the network latency. Next part would be what you're doing. So that's where your app is, the transaction time. That is whether it's your app queuing in your web server and the whole request response cycle. Then finally, there's the browser, how fast it will render the entire page. Maybe it's going to be a blank screen for a second or two. Maybe it's going to display it immediately. So in terms of metrics, the network, it depends on the type of network you have, the ISPs of your user, the geographic location of your user. So that can vary widely, 200 to, I don't know, 3 seconds if you're using Philippine internet. Then your transaction time, it can vary. It depends on what your app is doing or whatever. Then the browser, it depends. If you have a poorly optimized single page app, it's going to be pretty slow at the start and might be faster as you go along. So that's your load time. The ideal load time would be less than a second. If it goes greater than that, it's kind of jarring in terms of experience. If it goes greater than 5-10 seconds, your users will just hit the back button or find something else. So how do we improve the performance here? Well, one way to look at it would be, I forgot to mention, given this breakdown, what you'd want to have in your application would be around 300 milliseconds, 250 milliseconds. That should be enough to cover both the network and the browser load time. So given this situation, how to improve it, one way of improving it, or one way of looking at the problem would be to look at where your servers are. So this is one weird trick to cut down your page load time. So if your users are in the Philippines in your application, most of your users are in the Philippines and your servers are halfway around the globe, if you want to really cut down your time, well, you can get a new framework that produces results in 50 milliseconds, or you can just move your servers closer and you cut down on your network time. So that can cut it down from 500 milliseconds down to, I don't know, 150 milliseconds. That's normal from Philippines to Singapore or Tokyo. Or if you really want it to be fast, you can host it directly in the Philippines. So that will even cut it down. So point is, if you're looking at it in terms of what you want to improve, there are a lot of things that you can do. So if you just want a quick thing to improve your user's experience, one easy way to do it is to just move your server, if it's possible, because it's hard to get data centers here in the Philippines. Anyway, so that's the idea. Think of how you can improve the performance of your app and look at it both in the latency part and the throughput parts. Now, first step in doing this would be, as I mentioned, you have to get some metrics first. I'm just going to run through this because I think Will has already talked about most of this. And there's this obligatory news quote about premature optimization. You don't want to optimize prematurely, thinking that you need to optimize your stuff when in reality you don't really need to optimize it. But you should take advantage of the 3% possible things that you can optimize. And one way of looking at it, one way of finding out what you need to optimize would be to get some metrics. So yeah, Will has already mentioned about analytics, looking at production, see where the pain points are in your user's experience. So this is not really analytics, it's more instrumentation. It just doesn't look like good when it's 2 lines. But anyway, the point is, Will already mentioned New Relic. So New Relic instrumentation and all of its alternatives like Skylight, it provides you with, it provides you a good view of what your app looks like, how your app's performance looks like. So this is an example. This is one of our apps. So right now, I don't know if you can see it, it's averaging around 75 milliseconds in peak hours, and that's just a basic Ruby app. And this is one of the, and I mentioned before, almost no expense. These things cost a lot per server, so this will be the best expense you can make when you're trying to improve the performance, improve the experience of your users. Just a quick rundown of what you need to look at. Aside from the mentioned in the talk before, for lunch, so page load time, look at not just the averages, look at the 95th, 99th percentile, see how your app performs for the 1 in 20, 1 in 100 cases, because you might not notice some of those paying customers have really bad experiences. You have to look at what the problem is there. And also the slowest queries, slowest pages, slowest API calls. Queuing time, that's a problem with your server. You can see before it's there's a slight bump there because Heroku restarted in the middle of the day. Then there's the CPU and memory load so that you know how much more load you can take. Ideally, there's really no rule of thumb here, but I guess 60 to 70% CPU and memory is good enough. But if you go higher than that, you might want to look at increasing the amount of servers. But again, still load test, because if you want to do some changes to your application to improve the performance, you still have to get some metrics on the before and after. And well, you can directly apply to production. It's generally not a good idea to have that as your first choice. You should try doing the load test locally or in a staging environment. There are tools that Will didn't mention because of probably NDA. So this is what we are using in some of our projects. This is an old project in 2015. It's really bad. You can't see it, but it's around 6 seconds. That's the before. After we got it down to around 500 milliseconds. But point here is you have a load testing tool. You can produce repeatable loads for multiple tests. Profilers, we'll already mention a lot of this. So this is the Ruby prof. This is the looks very cluttered. So if you scroll it, this is a screenshot, if you scroll it back there's going to be a lot of Rails code, but this RubyConf shows the stack trace, the call tree, and see how much percent is spent on part of your application. Next would be the profiler. This is just a flame graph. It shows you a snapshot of the stack trace every few milliseconds. And this is a bad flame graph because there's a lot of repeated stuff, and you want to have that as little as possible. And depending on the tool you get, you can have a thread profiler. New Relic has this, so if you have just turn it on after 5 minutes, it's going to check every 100 milliseconds, every thread, and see what the stack trace looks like, and see where your app is spending most of its time. So this example, I'm not sure you can see it. Our app is spending around 9% of its time just doing number with precision. So good thing this is not production, this is a load test, so we hammered one page, so we saw that that page is spending a tenth of its time just converting a number to something with commas and decimal point. So that's one of those root cause finding things. So again, it's a basic, just measure, find the problem, then test, then apply to production. Yay, this is just basic clip part. And the testing, good thing, Will already mentioned it, so if someone asks a question about testing, well, I can just ask Will about it. Anyway, so what can we do to improve the performance? Since I came from the enterprise before I got into really Rails web development, I have a good background in databases. So the problem is most Rails developers aren't really that good in databases. So usually your bottleneck would be in the database. And another problem is it's not really talked about anymore, how to improve your database performance. Everyone's talking about the latest JavaScripting, the latest containerization thing. They're not really talking about making Medium posts about that anymore. So it's not really focused on. But the good thing about database tuning is, as Phil mentioned, there's tools like Bullet. The good thing about Bullet is the most common problems, it shows it directly to you. The N+1 problems, which you can solve by using includes, eager loading the stuff. And it also shows you if you went overboard with includes, and shows you unused eager load, and also saying if you need a counter cache for query. So going beyond the bullet, you have to improve the performance of your indexes and your tuning the queries, and get the most out of your database. So just a quick overview of what these things are. So the index is, it's for faster lookups. Essentially, you're making lookup table, not really lookup table, lookup tree extracted from your database that makes lookups faster at the cost of extra space and extra overhead when you're inserting and deleting. So ideally, when you're querying, that query should use an index. And the thing about indexes in Rails, Rails provides you with ways to customize your indexes. So not the basic single column, multi-column indexes. You can provide the indexes with an order. And I think just one of the things I enjoyed learning about in the past few years is this partial index thing. Partial index, you provide some sort of where clause where it will create the index, but only for that expression. So if you have a really big table, so comments, there are just a few people with no comments, the index it makes is far smaller, so it wastes less space, can be stored in the memory, and it can be faster. So that's a partial index. I think it's only supported in SQLite and PostgreSQL. So apart from this, other options, it depends on your database. If you're using MySQL, there's other things that you can add. For Postgres, like this, you can have, I think this is an expression and the operator something. I never got to use this, but it's a good option to use if you need it. And when we're talking about indexes, how do you know that you're using your indexes properly? Well, you can get your query plan just by appending .explain to your active record queries. So the explain call will print out the query plan, the execution plan. It shows you how your database is looking up the data from your databases, whether it's going through the indexes or whether it's going through all the records. Not sure if you can see those things, but this can be bad because you might notice that it's all using sequential scans, and if you do queries and you do an explain plan, the ideal is you don't want your database to have lots of sequential searches. You want your database to do index scans and the like. But this is okay because if you can see it, the rows is just one row, and this is just a development database. It might actually be better for the database to go directly to the index and just sequentially scan it because the data is pretty low. So this is how you analyze your indexes. This is a big topic. You have to research it on your own. But if you are tuning your queries, this is something that you will get to use quite often. Another thing, a downside of using ORMs is people are afraid of using joins. People are just using what active record is providing. It's sort of a black magic especially for new developers. And eventually, yeah, new developers are afraid of using SQL. They try to do everything in what active record provides. But the thing is, you want to have multiple options when you are querying, especially if your queries are getting slow and you're querying a lot of stuff. So this is a very, very simple example. Find parent records without children. So how do you do that in active record? The simplest way is to just add a counter cache and select everything where the counter cache is 0. But if you can't do that, one option would be to do it purely in Ruby. So just get all the items and select everything where the item are empty. So that's two SQL queries. A good thing there's eager load to get all of those info. Another example would do the outer join. This is the old style outer join. I think this is Rails 3 and 4. For Rails 5, there's already a left joins, and just find the item where the ID is nil, so there's no relationship with any item. And another option would be to do it in SQL, which is to use not exists. And in some cases, not exists can be more, it can be faster because when it finds an item in the database, it already stops. And in some cases, it doesn't. So again, measure before you do stuff, so you can know whether it's working or not. So knowing SQL gives you lots of options. And if you're afraid of doing joins because you're worried about n+1 queries, n+1 things, there is undocumented private method to eager load stuff when you do a find by SQL. So this is a find by SQL. This is I anonymized the big select statement that we had there. And that won't preload everything. So if I call the message.account, it will do an n+1 call. But I can use the preloader.new. This is not documented. It's not advised to use this. But yeah, you can eager load joins if that's the thing that prevents you from doing joins. I think last part about databases is if you're doing full text search, you're searching for text, you probably would use like %, something like %. That's a wildcard search. That's going to be really slow. But you have a lot of options. First, you can just use what the database provides you. PostgreSQL, actually all the modern databases have full text search. And you can just use a gem that supports it. So Textacular, just add it and you can do a .basic search. Or you can use an external search engine like Elasticsearch. It's a lot faster, it provides more features, but it provides another point of failure for your application. And we've some of us have experienced that where your app just shuts down because Elasticsearch crashes. But your app is still up, so it doesn't ping you that there's a problem. You just get a lot of error 500s. But it's a trade-off. At least you don't use the like percent something percent. I don't think we have a lot of time, so I'm just going to run through the rest. Guess I just have to cover caching. Good thing about caching, there's a big page in the Rails guide all about caching. Just go through some of the notes that we've experienced when we're using caching. So Russian doll caching allows you to nest caches in your page fragments. The problem with that, the good thing about that, it makes your pages load faster if a lot of people are using it. I guess the main problem with that is it can get really complicated sometimes, but the real problem I had lately is it doesn't really work with JBuilder. You're going to have to do other stuff if you're using JSON. Another thing, low-level caching. This is how you cache stuff using the Rails that cache at fetch. If you have your application accessing something, whether it's processing something over and over or accessing an API, it caches it somewhere and every part of your system can retrieve it. It's good for APIs, especially if your API is slow, what you're consuming is slow, and also for serving API response. You can cache what your result is and just send it again later on using Rails that cache that fetch. Guess ideally you should use race condition T time to live to if you're using expires in, so expires in 1 hour. At the end of that time, everyone's going to use that cache and it can hammer your system. If you use the race condition T time to live, it's going to set a time wherein only the first can regenerate the cache. And I think I doubled that. In terms of cache stores, moving on to cache stores, the point is the default is okay, unless you're in a server that doesn't allow a file type cache store. Memory cache store, we've used that. The problem is it kind of eats a lot of memory, but it's pretty good. And it also has the same problem as a file. If you're only using one server, it's okay, but if not, it's not shared. If it's shared, you can use Redis and Memcache, but again, that's another thing to worry about. And lastly, about caching is conditional get. If you know that something is already the same, so it's the second time the user access that thing, say it's a big JSON file, it doesn't change every day, you can use caching to tell the user that using tag or last modified, so that say if it's a 5 meg JSON file, instead of returning that, you can just return a 304. Anyway, just a quick run through. It's good for APIs, as I mentioned. Quick run through of the rest. Performance tips. So we're running out of time. Upgrade your Ruby gems, Ruby and Ruby gems. That's really a good idea, and a lot of improvements happen between upgraded versions. Though sometimes there are regressions in performance. So again, you have to just test it. You have to tune your everything, your servers, your databases, but that's another topic altogether. And this, again, that won't cost you anything anyway, just the sanity of your sysads. Next would be templating. Again, if you like Haml, it's okay, but just know that it can be slower than ERB. There are options. We haven't tried Hamlet. It's supposed to be faster, but we can't really vouch for it. It says it's at least faster than ERB. Also, for your resources, you might want to try HTTP too. So if you have lots of images, it can send all the images, or better yet, just use a CD and let them worry about it. Anyway, just wrapping up the talk. So this is my main source of what we do for our performance testing, performance tuning. So this is Speed Shop. That's Nate Berkopek's blog. That's his old blog. He turned it into a business. So most of the performance tunings, you can read it there. And in terms of SQL tuning, I guess the most accessible is use the index loop. Anyway, that wraps up my talk. Thanks. You can see me at, you can find me there. And as usual, Logica is hiring, but since this is a conference, it's kind of bad taste because your company is paying your conference fees and you're just getting hired for other things. So instead, I'll just plug our apprenticeship program. We have our own apprenticeship program. So if you have a friend or know someone who is a programmer but wants to try out Ruby, you can just go to our booth. And we're not really advertising this yet, though we already have one apprentice doing it. So if you want to have your friends learn the fun of Ruby, yeah, just contact us, approach us in the booth, and we'll tell you the details. Anyway, thanks. I guess that's it. Thanks for listening.
Thanks, Bryan. So we have time for one question,
one question.
while the next one is being set up.
Okay.
Questions? Well, none. Thanks, Bryan. You may approach him after for if you have any questions you want to talk about.